Okay, let's jump right into this explainer because honestly, we have some absolutely critical, literally life-saving information to cover today. If you're a professional cleaner, you've got to realize you aren't just removing dirt, you are a risk manager. And your absolute best tool for managing biological risk, it's understanding exactly what ppm, parts per million, actually means for you out there in the field. Grasping this is the absolute bedrock of infection control.
So to really get ppm, we need to anchor this massive number in reality, right? I mean, a million is kind of hard to visualize. So let's make it physical. Imagine a standard bathtub, maybe 13 gallons, filled all the way up to the brim with water. If you take exactly one single drop of chemical and add it to that entire tub, that is the mathematical reality of 1 part per million. It's a super precise measurement. It tells you exactly how much active, germ-killing ingredient is swimming around in your water. And it's the gold standard when microscopic amounts literally mean the difference between a safe room and a total outbreak.
Now, what's really fascinating here is the massive shift in professional responsibility when we talk about ppm in our industry. Think about it for a second. In air quality, scientists just passively look at a monitor to read the ppm, right? Water engineers just observe it to check for contamination. But in cleaning, you actively dictate it. You are the one creating it every single time you dilute a chemical, push a pump, or mix a bucket. In your hands, ppm isn't just a readout on a screen, it's an action. It's a deliberate choice. Which brings us to an absolutely unbreakable law of infection control. You cannot disinfect dirt. Period. If you spray a heavy disinfectant directly over organic matter, we're talking blood, vomit, heavy soil, the chemical actually attacks the dirt. It gets completely neutralized right there. And the dangerous microbes? They just hide safely underneath that organic shield, surviving your chemical spray completely unharmed. So you can't just spray dirt away. You physically have to remove that shield first so the chemical can actually do its job.
And because of that unbreakable biological law, your whole strategy has to split down two distinct paths. You've got one-step disinfection, where you wipe clean and apply chemical at the same time, but that's only for visually clean, low-risk areas. Think daily office desks or light touch points. But you must absolutely, without exception, escalate to two-step disinfection when you're facing high biological risks. Stuff like vomit, blood, diarrhea, or suspected outbreak, where the pathogen load is sky-high.
This two-step process is really your ultimate defense mechanism. Step 1 is the physical battle. Clean. You physically scrub away the visible dirt and body fluids using standard detergent and water, just to break that surface tension. Only then comes step 2, the chemical battle. Disinfect. That's when you apply the precise ppm required and, this is crucial, you wait for the full wet contact time on the label. Look, if you still see dirt, you aren't disinfecting. You're just wasting expensive chemicals. Step 1 removes the shield, step 2 delivers the killing blow.
Okay, let's build your understanding of the microscopic enemy, because not all viruses wear the same armor. We'll start with enveloped viruses. These guys have a fragile outer shell made of fat or lipids. Think of COVID-19 or influenza. Because their armor is literally just fat, they're actually pretty weak. It's exactly like how standard dish soap breaks down heavy bacon grease in a pan. Even mild, gentle chemistry easily pops that fat layer and completely collapses the virus.
Now contrast that with non-enveloped viruses. The notorious norovirus is a perfect example. These guys do not have that fragile fat layer. Instead, they're armored in a hard, tightly woven protein shell. It's basically a microscopic stone wall. They are extremely resistant to drying out. They literally laugh at alcohol-based sanitizers, and they can survive mild chemicals for weeks on a surface. To break through a shell like that, you demand a fundamentally more aggressive chemical attack.
So this means you have to choose your weapon based entirely on the enemy's armor. Acidic products, which sit low on the pH scale, well, they're your precise scalpel. Great for cutting through fatty enveloped viruses and way safer for daily use on your surfaces. But a scalpel isn't going to break a stone wall, right? For norovirus, you need alkaline disinfectants like high pH chlorine. This is your heavy hammer. It brutally smashes the proteins in non-enveloped viruses, but you gotta use extreme caution because a hammer can easily damage the surfaces you're trying to clean.
All right, now that we know exactly when to pick up our alkaline hammer for those really tough jobs, let's deconstruct the exact ppm ranges you need to deploy based on real-world biological risks. This right here is where your professional judgment truly shines. We're going to break down the 3 main tiers of application to act as your core operational guide. Let's look at Tier 1,
For low biological risks, say a small urine spill or minor secretions on a bathroom floor, 500 ppm is your golden standard. The pathogen load here is relatively low, so using 500 ppm is just the mark of a really smart risk manager. It completely controls the biological threat, sure, but it also protects the floor's finish, stops your building from smelling like a swimming pool, and, frankly, protects your own lungs from unnecessary chemical exposure.
Stepping things up to a moderate risk, you elevate your mixture to 1000 ppm. This is your safe, robust middle ground. You want to deploy this for small, fresh blood drops, unclear bodily fluids, or for widespread surface wiping during a general respiratory outbreak, like COVID-19 or flu season. Basically, 1000 ppm gives you that confident, necessary margin of safety for unknown threats, without crossing the line into absolute overkill.
Finally, we hit Tier 3. For the absolute highest stakes environments involving massive pathogen loads, we're talking vomiting incidents, severe diarrhea, large blood pooling, or a confirmed norovirus outbreak, you absolutely must escalate to 5000 ppm. But hey, remember our unbreakable golden rule from earlier? This incredibly high, highly corrosive concentration must be applied strictly after you have physically cleaned and removed the mess. Remember, dumping 5000 ppm directly onto a pile of vomit is just a complete failure to disinfect.
You know, it's an incredibly common but super dangerous professional error to just mix everything at 5000 ppm just in case. Let me be clear. Safer does not mean stronger, and stronger definitely does not mean safer. Needlessly high ppm literally strips the coating off floors, it rusts expensive medical equipment, creates highly toxic respiratory fumes, and leaves this sticky residue that causes severe slip and fall hazards. Throwing maximum chemicals blindly at a problem isn't being professional, it's a fundamental thinking failure. You have to precisely match the chemical strength to the actual risk.
So, when an outbreak strikes, just stop. Don't panic, and definitely don't just grab a bottle out of blind habit. Run this deliberate checklist in your head instead. First, identify. What are the exact symptoms? Is it vomiting, meaning a screaming norovirus, or is it coughing, suggesting an enveloped virus? Second, choose. Pick your chemistry, the scalpel or the hammer. Third, assess. Is there visible dirt? That tells you if you need one-step or two-step. And finally, select. Lock in your precise ppm number.
As a risk manager, you're constantly balancing two completely different but equally vital safety layers. Think of it like a scale. The chemicals and the ppm you choose to apply to a surface, those are there to protect the vulnerable patient or customer who will walk into that room tomorrow. But your PPE, your heavy gloves, your goggles, your gown, that exists entirely to protect you right now. Wearing PPE while failing to disinfect correctly only protects you. Disinfecting perfectly while ignoring your PPE endangers your own life. You absolutely need both.
If you want to truly master infection control, you have got to ruthlessly eliminate these field failures. Spraying expensive disinfectant onto raw dirt. Using a gentle, acidic cleaner against a tough norovirus shell. Guessing your ppm levels by just eyeballing the color of the liquid in the bucket. Or, my personal favorite, choosing a chemical just because the fragrance smells nice. Guys, these aren't just lazy mistakes. They're catastrophic thinking failures that lead to silent, invisible disasters where outbreaks spread completely undetected.
Ultimately, this is your line in the sand. This is the exact difference between an amateur who just wipes down a table and a true professional who actually manages biological risk. Are you going to rely on blind habit, or will you choose to control invisible threats with visible, calculated responsibility? By truly understanding the chemistry, respecting the pH, visualizing the virus structures, and mastering the mathematical reality of ppm, you completely elevate your role. You aren't just a cleaner, you are a vital shield for public health.
I really want to leave you with this final, uncompromising rule to carry into every high-stakes environment you ever walk into. Dirt first, microorganism next, ppm last, and never, ever guess. Clear the physical battlefield, identify your viral enemy, choose your chemical strength with absolute precision, and please, never leave human safety to chance. Thanks for joining me on this explainer. Keep managing those risks out there and definitely stay safe.